Hi, my name is Chadwick. I'm a DaVinci Resolve master trainer and finishing artist based here in New York, and this is part one of a 5-part mini course offered for free here on YouTube on how to do inpainting using the Fusion page of DaVinci Resolve Studio 21 to remove a sticker off the outside of a Ford Bronco. Now, inpainting, if you're unaware, it's basically what Photoshop calls content-aware fill. It's basically a great technique to remove logo when you have edge colors that can be sort of carried across. Now, in part one today, what we're covering is project settings, things for color management, noise reduction, tracking, and resolution optimization. So it's really a good foundation for the rest of what we're going to be covering because there's 3 different techniques for inpainting. So in lesson 2, coming out tomorrow, is going to be all about how you can use the paint smear tool, which is a lot like the drag tool from other applications. In part 3, we're covering how to do channel math to grow our edge pixels using a blur and divide technique. Part 4, we're looking at the clean plate method to do inpainting. And part 5, probably one of the most important parts of a seamless composite, is how do we add back texture. So I'll be covering frequency separation to add back our original textures, as well as the original grain. So if you're up for it, I'm super glad that you're here and joining me for this course. You can get the footage to follow along if you want to. It's up at creativevideotips.com by joining Cutting Club. You'll have the same clip. And if you just want to support the channel, that's a great way you can help support my free teaching efforts here on YouTube. With all that out of the way, let's get started. Here is the clip we're going to work on. It was shot with an iPhone 16, so it's Apple log. That's important to know. Anytime you work with log footage, you should find out exactly the color settings that were used. And we want to color manage this for visual effects. The best way to do that is just using project-wide color management. So the way you get to that is in the lower right, there's a little cog down there. Click it or hit Shift-9, it'll get you there as well. The 4th one down is color management. Change color science to not be DaVinci YRGB. Change this to DaVinci YRGB color managed. Change color processing mode to HDR. And this is perfect. If you have log footage or raw footage, you want to set processing mode to HDR. That will retain all of that original dynamic range really well. And then SDR Rec 709 means, hey, we're going to view this on an SDR display, a regular computer screen, a phone, a regular TV. The only other setting I would change in your project settings is under the Fusion tab. If you want to match me, change your default start frame to be 1001 instead of 0. The reason we change this is because if we ever need to add extra handles to the beginning of a shot, it doesn't require us to go into negative frame numbers at all, which is very confusing. This gives us numbers that are lower than 1001, so we stay with positive numbers. All that done, hit save, and nothing has happened. Why? Well, footage has to also be tagged. Now, the raw footage will automatically be converted. It should look proper now, but if it's not tagged and it's not raw, you might need to do that. So the way that's handled in Resolve is you right click on a clip in the media pool. You can do a bunch of these at once. And because color management has been turned on, you can come down here to input color space and then just choose the camera that shot the material. So I'm looking for Apple and Apple log, not Apple log 2. Apple log 2 is iPhone 17 and probably newer if this is watched later on down the road. But because this was shot with an iPhone 16 or a 15, it would just be Apple log. It's a different set of primaries, so you want to get that correct. There is a right and wrong here. It's not a creative decision. So if we want to get this into Fusion, all we got to do, drag it down to a timeline. Timeline resolution doesn't matter because when we open a clip this way into Fusion, it always gets all of the original pixels, so 38, 40 by 20, and 60, and it will retain things like source timecode if you render this from the deliver page for a final output. So let's open up Fusion and turn this into a Fusion comp. Fusion button right down there at the bottom of the screen. It's a little magic wand. And the first thing you might notice is, well, one, I'm looking at a mid-flow vertical layout. So if you're new to this, I work top down, not left to right, more like Nuke. If you go to Workspace, Layout Presets, Fusion Presets, mid-flow vertical, that'll get it so your node graph is sort of in the middle between your inspector and your viewer. You may have 2 viewers visible. I typically work with 1. Just choose the viewer you want to work on, which is done by selecting this button right here, this rectangle on the one that you want to view. And the only other thing I would say is you're viewing this with a viewing LUT on. In other words, when you turn on color management, it takes your footage from the log space that you're actually working in on the timeline into linear, but it's always showing this with a viewing LUT. So in here, if I disable the viewing LUT, that's this little waffle checkerboard thing in the upper right. If I disable it, that's the linear image. That's the math that the pixels actually operate on, which is generally perfect for most compositing operations. There's exceptions, and I'll talk about those when we get to them. But just know you're operating in linear. You're viewing it with a 709 transform on it, and it's controlled with what's called the Fusion View LUT. If you hit edit, you can see it's controlled with managed color space. It takes care of it for you. There's lots of other viewing LUTs you can choose in here as well. This is just the one that works best when you're doing color managed workflows in Resolve. All right, now that that's out of the way, let's talk about color channels a little bit because it's going to help a lot when we do our noise reduction on this footage. So the first thing I want to point out, right next to the viewing LUT, you've got the different color channels for the viewer. Right now we're looking at C for color. This is R, G, B. Those are the shortcuts, by the way, red, green, and blue. And when you're analyzing the footage for noise, it's good to look at the individual channels. So the red channel has quite a bit of noise. The green channel actually doesn't have the most amount of noise, generally. And then the blue channel is usually the worst. So the first thing I usually jump at is the blue channel to see how many artifacts are in this, what's worth removing. But the idea is we want to remove noise when we do paint work because, one, if you paint on a freeze frame, which is not what this course is about, but you never want to paint on frozen grain. But besides that, we want to be able to extract things that were not actually in the scene. The noise is an artifact of the camera. We're just going to put that back on at the end of this course. So we're getting rid of it while we paint. So when we smear things, we're not actually smearing the grain that was actually there in the scene. We're just going to extract these technical errors, with noise reduction. Now, I can't see a ton of artifacts with my normal viewer. The other piece of the viewer that's really, really helpful is gain and gamma sliders. So the 3-dot options menu can pull these up. It's called gain and gamma. And this is also just to help you view things. It's like a microscope for your viewer. You can check that and it pops that up. You can also just hold this waffle button down. It appears and disappears as you hold that. That's the way I actually prefer to turn it on, and we'll continue from now on. But what I want to do is decrease the gamma, increase the gain. That increases contrast, especially when you're in the linear domain like we are right now. And one thing this can be really helpful to do is to reveal things like compression artifacts, which is common even if you don't feel like there's a lot of grain in the image. And the noise reduction built into DaVinci Resolve Studio can help remove these compression artifacts in these lines. So to do that, I'm going to add noise reduction next. So shift space, noise reduction. I've got neat video as well, but I'm just going to show you with the built-in tool because you probably have it if you have Studio. You do have it. And I'm just going to focus on temporal noise reduction. Now, the temporal basically is comparing frame to frame by frame, what's different between them and averaging them out. It's where I would generally start. I'm just going to keep this really simple right now and just change this. So we're going to choose motion estimation type to better instead of faster because faster is actually not very good. And I want to retain some quality. And then you just increase this threshold slider, and you should see here in the viewer, because I've increased the gain and gamma, and I'm looking at just the blue channel right now, because I increase this, and if you hold command while dragging these numbers, you can get finer increments. I'm just trying to get rid of some of those compression lines that were in there. And if you can actually see quite a big difference if you turn it on and off with not a lot of very high value. I'm only at like a value of 2. Maybe we'll set this at 3 so we're all at the same page here. Turn that back on. And that has cleaned up the image significantly, even though your eye probably can't see this change. When we view this in C for color mode and disable our gain and gamma viewer, if you turn this on, off and on, you probably can't see this to your eye, but the computer can, the tracking tools can, and so it's a great idea to always employ noise reduction right at the beginning of your flow. And the other thing I'll point out is you're not getting the best performance when you apply noise reduction. It's a very intense thing for this computer to basically, when it says 3, is comparing basically 7 frames to calculate 1 frame. It's going 3 frames left and 3 frames right of the frame that it's on to average those out. So that means we're going to talk about using a saver node next to sort of pre-render our noise reduction. So the saver node, shift space, saver. Saver node is basically rendering out an image sequence in EXR, which is ideal because we're already working in linear. EXRs are for linear. And the settings we're going to use to do this pre-render is go to the Format tab of the inspector, use DWA 256, With the compression set to 45 is ideal. Float 16 is ideal for footage as well. The only reason you use float 32 is if you're using things like optical flow or mathematical passes in it. I'm going to come to the original footage. This is a little trick here. So the original footage in Resolve 21, on Media N1s, it actually shows you the original clip name, which is super useful. You can select that by just double clicking, right click, go edit, copy, come back to rename, browse, and then find a logical place to place it. So I've got a folder in, let's see, Red Bronco Paint. I'm going to create a new folder in here. I'm going to right click and say paste, but I am going to change the end of it. I'll call this just Denoise so that this image sequence is written out into that folder. Then I'll double click the path up here where I say rename V1, which is this is probably going to be untitled for you to start. I will right click here and say paste and append Denoise. And then you'll notice here at the end, I do ... so 2 periods, then EXR. This just puts a little separator for the frame numbers between the N and the frame numbers that are going to be inserted in between those and the file extension. I'll hit save. And then to actually render it out, all you do is you come up to Fusion, render all savers, and this is baking out these frames into that folder. Anytime you do video editing, there's always like this pay now or pay later sort of methodology. And when it comes time to deliver, you never want to pay then because you're always under a time crunch. So that's one reason I suggest you always render out your denoise plates if possible, because we don't have to wait for this, 1.76 frames a second later on. We just have this done and it's out of the way. So I'm going to click OK. And to get the footage back into our flow over here, all I'm going to do is click away, and anywhere you click is where the node's going to drop, a new node, and we need to load a loader. That's how we reload the rendered footage. So shift space, LD, is our loader. And the cool thing is the loader knows exactly where you just rendered out your last piece of media. So this is our Denoise Plate. Just select the first of this entire image sequence of EXRs. And we've saved a lot of space because we use DWAB compression, which is a lot like a ProRes 4x4 when you use that 45 compression rate. It's great for most cases. It's not lossless, but it's still very good. Now if I load this into the viewer, let this cache through the first time, and now we're not going to ever have to wait on that noise reduction node ever again. We've got our Denoise Plate. Next, I want to talk about resolution optimization here on the Fusion page, and that deals with cropping images to just the area you want to work on, especially if you're using the Paint tool, which we're going to be talking about in upcoming lessons here in this course. And the way the crop tool works to cut the resolution down would be shift space, CRP is the shortcut to add that to the flow. We're going to work on the Denoise Plate from here on out until we're almost at the end where we add the original grain back. I load the crop tool into the viewer. That's just a pick and flick, or you can hit number 2. It's this little icons letting me know that's the state of the image that I'm working on. That should be a Fusion 101 course available somewhere else. But the way the crop tool works is in the upper left, we have this allow box selection. So when you click on that, make that active, you can click and draw a rectangle box on the frame. And the idea here is I just want to isolate just the area of the Bronco that I'm going to be working on, covering the door area, which something like this is plenty. And this, you can see I've cut the resolution quite a bit. I was at 3841 across. Now I'm at 2163 across. This is going to increase your performance, your RAM cache, everything quite a bit. So I strongly recommend you always crop to the paint areas that you're going to need. And then at the end of this, we just place it back on the original pixel grid. What you do for that is you take the crop tool, Command-C, Command-V, and then on the second version of the crop tool, I'll load that in the view, just pick and flick is how I drag that over into the viewer. You can see crop 1_1. And this one, we just say, what was the original size? That's the original resolution. If you forget what it is, just pick and flick to load that in. It's 3840 by 2160. So I'm going to punch that in over here. 3840 tab 2160. And then the offsets are just negative values of what the original one was. So if I use my arrow keys, you can do this really easily. So just a minus in front of that. And then just do a minus in front of that one. And this just placed that section back in the exact pixel that it came from. But the idea is we're just going to work in this little crop section of the flow here so we minimize resolution and we get faster renders. Make sense? So here's how what we would be doing is, here is our cropped image. If you're new to Fusion, welcome to the merge node. That is this node right here. This basically says we're going to take our original Denoise Plate, place our cropped version back over the top of it, and we've reconstructed our image. But we've given ourselves a little bit of a sandwich here that's a lower resolution to work on. That's all that means. Now, the next step is going to be talking about stabilization so that we can take into account lighting changes. Planar tracking. So let's get the planar tracker after our crop. So shift space, PTRA, there's our planar tracker. The planar tracker is basically going to track, it's going to try to find points in texture over time and average it out is how it works. I think what we'll do is we'll start this on the end frame. 1122 is what I've got. And once it's selected and you drag it in the viewer, you have a little plus cursor icon. And the idea is you just, on the same planar surface, make a selection, like a window here, of all kinds of texture and detail. Now you want to make sure you close it up. You'll see that, you'll know you'll close it up because you get that little circle there, or you can hit Shift-O. That will close up the shape. And then once we've done that, we need to set a reference time. Right now it's set to 0, so that's no good. We need to set that, and so it's being set to our current parked frame that we drew this on. And then you've got two different algorithms. It's really one with an added layer. So I'm going to choose hybrid point area, which is basically point with an extra feature that basically goes and throws out what it thinks is bad data. And because it's a hard moving surface that's moving like this, it's actually moving in perspective, so that's good for motion type. But if it's too complicated of a motion and it can't find that, it's good to come up this list, which is actually less complexity as you go one by one to try to grab tracking data. And we'll just see how this does. I have a feeling it's going to fail because there's reflections, and I have a solution for that. So if I hit track backwards right here, we'll see how it does. It appears to have done fine, but you never know how well the tracking data does while the track happens. The only way you can actually check the tracking data on a planar track is change this over to steady mode. And in fact, I will steady this along the same frame that we tracked, which is at the very end, 1122. I'll hit set. And so we're going to check this to see if it's stable or completely locked off, which is what we're going for, by placing our cursor on a point, hitting play, and seeing if it moves. And in fact, it completely disappeared. It lost track of everything. And I see this happen a lot on YouTube comments and think that the planar tracker is broken. No, it's not. It's just very sensitive. And the reason what's happening in this original image, if we turn on our viewing gain gamma over here, let's see, there you can see some of those reflections in there. It's actually picking up, there's that texture. There's reflections that are happening that are basically reflecting off the shiny surface, and it thinks those are part of the texture, and so that's why it's failing. So we want to remove that extra texture that's in there, but still use that same shape that we originally started with. And the way we can do that is using a technique that's called frequency separation. So I'm going to come back to our original crop node and perform frequency separation on this image here. So we're going to actually track just the details. That's the idea. So to do a frequency separation after the crop node, we're going to need two things. We're going to need a blur, and we're going to need a channel booleans to do some division for us. So the blur node can be grabbed from your toolbar. The channel booleans is also up there. You can do shift space channel booleans. Make sure you get the one with the S. And the way you'll set this up is you're going to feed the original crop image into the blur. Just a little bit of blur is fine, at least to start. I've got it set to 1. And the channel booleans is going to be set operation to divide. And then it's also a good idea, do nothing to the alpha channel. Just leave that alone. Now, this is the only thing is this is hooked up backwards. I want to take the crop into the background, the blur into the foreground. The easiest way to swap this is Command T or Control T. That will swap your inputs and outputs. And now what we've done is we've just extracted the texture, and we've negated all of that reflection that was more in like the lower frequencies. So we can just track on this texture instead, and without doing anything other than just retracking, let's see if we get a better result. So I'm coming back to the planar tracker, going back to track, and if you just track all the same settings as it was before, it should just overwrite the existing track data. So I'm going to track backwards. Let's see, let's load the planar tracker into the viewer. And to my eye, it looks like that has stuck much better than it had prior. I'm going to go to reference time, click go to steady, and it's steadied on 1122, the end frame. And now let's see if that tracked better. Look at that. My cursor is basically saying, hey, that entire door or everywhere within that polygon that I drew with the planar tracker is not moving. That's perfect. That means this is a solid track using the most complex mode, which is hybrid point area set to perspective. We just had to get rid of that extra detail, those reflections, and that's how that is done. So now that we have a planar track, we don't actually need this frequency separation at all. So I can delete that. That was just to get data for the planar track. It's setting a bunch of keyframes is what that is doing. But I do want to view this in steady mode, because the benefit of this is if we've locked this off, we can paint on this as if it's a single frame and then just reapply the motion later on. The way that is done is just like we had a crop sandwich. We take this planar tracker, hit Command C, Command V, an exact duplicate of it, and down here in the flow a little bit later, the second one, instead of saying steady, we leave that on steady, but we choose this thing that says invert steady transform, that little checkbox. This applies the original motion again, so we're back to square one. We basically created this whole, you know, if you've seen these ideas, these color space transform sandwiches, we've created a stabilized crop sandwich here that we can do all of our work in after this planar tracker right here. So to recap lesson one, what we've done today is we've turned on our color management for DaVinci YRGB Color Manage HDR, and we tagged our footage, so we're working in linear. We did a denoise on the footage using the noise reduction setting 3 set to actually just the better mode set to a threshold of 3 was enough. Then we used a saver and a loader to sort of pre-render it out. We do all our comp work on the saved denoise version of the plate. Then we did a crop to lower the resolution so the operations are much, much easier to deal with and the render times are faster. We did a planar track. We did that on a frequency separated version of the footage to get a locked on stabilization of that door. And then we've just inverted those. So we've inverted the motion using steady set to invert steady transform. And we've uncropped it by setting the resolution back to the original and negating the offsets and then merging all of that back over the original so that in tomorrow's lesson, we can focus on the paint tool and using smear to fill in where that logo actually is. I hope to see you there. Again, my name is Chadwick. Thank you so much for watching. And because there's so much more to learn, I'll see you in the next video.